Alright guys, here we go. This is the video lesson for 9-2, factoring using the distributive property. And I actually think of this as undistributing, and you'll see what I mean by that in a minute, but you might hear me use the word undistributing. So first of all, let's start with a definition of what factoring is. And to factor something is to express a polynomial as the product of polynomials. So looking at example 1 there, you have a binomial, and we're going to change that so that instead of a binomial, it's going to be a polynomial times another polynomial. Okay? So looking here at example 1, this is the reason why we talked about GCF. If you think about the two terms 15x, and let's move this over here. If you think about the two terms 15x and 25x squared, you need to figure out what the GCF of those two terms are. Well, again, you could use factor trees, and you could say, well, 15 is going to be 3 times 5, so this will be 3 times 5 times x. 25 is 5 times 5, so this will be 5 times 5 times x. So the GCF will be just 5x. Now, like I said, as you guys get better at this, you should be able to just look at this equation right here and see that the GCF of 15x and 25x is 5x. Okay? Now, what we're doing with this is we are actually going to what we call factor out, or take out from each of those two terms. We're going to factor out a 5x, which means factoring out really means dividing out. So you're going to divide out the 5x. You do write that 5x out in the front, and now you divide it out. You're taking out 5x from both of those terms. So this then is a review of dividing monomials. You look here and you say, okay, well, 15 divided by 5 leaves me with 3, and this x to the first and x to the first just cancels out completely, so you're left with just a 3. Then I have this plus sign which comes down, and now you say, well, 25 divided by 5 is 5, and you have x to the second over x to the first, so 2 minus 1 leaves me with x to the first. So this is how you factor problem number 1. Now, a nice thing too is you can always double check your answers here by simply redistributing. Like I said, I kind of think of this step here when we take out the 5x as undistributing, because you're taking it out, you're dividing it out. Well, if you want to check your answer, just redistribute. What's 5x times 3? Well, 5x times 3 is 15x. And then what's 5x times 5x? Well, that's plus 25x squared. And you should always get back your original problem. But this is what we're looking for here. The factored form of 15x plus 25x squared is 5x times the binomial 3 plus 5x. So, let's do it again here in number 2. We're going to look at this term. This is a trinomial. We're going to figure out what the GCF is so we can take it out of all three terms, factor it out, or undistribute. And now I just need to figure out the GCF of 12xy, 24xy squared, and 30x squared y to the 4th. And again, you need to be getting quicker at this, so I'm going to look at the whole numbers, 12, 24, and 30, and I'm going to say, okay, well, they're both divisible by 2, but I think they're both divisible by 3 also. You know, that's true. Are they both divisible by 4? Yeah. 5, no. 6, yeah. So the largest thing that are all divisible by is 6. And then I look here and I say, first term has one x, the next one has a single x, and the last one has two x's, that means they all have at least one x in common. The first one has a single y, the second one has two y's, the third one has four y's, but how many do they all have in common? Well, they all only have that one. They all have at least one in common, so my GCF is 6x. Or, sorry, 6xy. So I'm going to factor that 6xy out, and then I'm going to leave my parentheses here to show what's left over after I factor it out. And again, factoring out is like dividing it out. So I'm going to divide out 6xy from all three of these terms. Again, this is why we practice that division. So let's see what happens here. 12 over 6 is a 2. X's cancel, y's cancel. 24 over 6 is 3. The x's cancel completely. 2 y's over 1 y leaves us with 1 y. Negative 30 over 6 is negative 5. There will be a single x left because 2 minus 1, and then there will be 3 y's left. And so there is your answer. You have factored out the 6xy, factored out the GCF. All right, looking at problem number 3, I'm going to make a slight mistake in this problem and show you how you can easily correct it. So I'm going to look at 16xz minus 40xz squared, and I'm going to say, okay, well, the GCF of these two, 16 and 40, let's say, is 4, which it's not. The GCF is more than 4, but I'm going to look at 16 and 40, and I'm going to say 4. And then I'm going to say, okay, well, here, I'm going to have to make this smaller so I can show extra work. So I'm going to take out the 4, and then xz squared means they both have at least one x in common, and they both have at least one z in common. So that's what I'm factoring out. So I'm going to divide out the 4xz, divide out the 4xz. So 16 divided by 4 is 4. The x's cancel, and the z's cancel. Negative 40 divided by 4 is negative 10. The x's cancel, and you're left with 1z. Now, I can tell right away that I made a mistake here because 4 and 10 still have a common factor. 4 and 10 are both still divisible by 2. So, in other words, this 4 out here was not the biggest number that I could have factored out. The biggest number I could have factored out was actually an 8, because 16 and 40 are both also divisible by 8. But since I made that mistake, it's fine. I can still come back and now factor out a 2. And my parentheses after you divide out a 2 will be 2 minus 5z. And then what do you think happens with this 2 out here? Well, it just gets multiplied. 2 times 4 is 8. There's that 8 I was talking about. So you end up with 8xz times 2 minus 5z. And again, you can always double check to see if this is right by distributing it back in. 8xz times 2 is 16xz. 8xz times negative 5 is negative 40xz squared. So you got back your original problem. That's an easy way to check to know if you've done them right every single time. This is a self-check chapter. Alright, so fourth problem. Again, I have 3 terms here. I'm going to put them in parentheses. I'm going to figure out what I can take out of all 3 of them. What do all 3 have in common? Well, since that's a 2, obviously the largest number they're all divisible by is 2. I can't say 4 because this 2 is not divisible by 4. The only factors of 2 are 1 and 2, so the largest factor of all 3 of those would just be 2. I'm going to then look at my a's. A to the third, a squared. So I have 3 a's. Oh, I'm sorry, I wanted you to change this problem slightly. Change this so that the second b here is a b squared. So make this b squared So I want to show something here. So let's go back to our a's. So I have a to the third, a to the first, a to the second. So I have 3, 1, and 2. So the most they have in common is just the 1a again. So just 2a. Now, b's, and this is why I made that change, because now there's going to be more than just 1b. With the b's, you have 2 here, and 3 here. That means they all have at least 2 b's, so b squared is what you're going to take out. Because now they all had at least 2. You're going to factor out how many they have in common. They all have at least 2 b's in common. So we're going to divide all of these by 2ab squared, 2ab squared, 2ab squared. So 2 divided by 2 is just 1, which you don't actually have to write. A to the third over a leaves me with a squared. B squared and b squared cancel. 8 divided by 2 is 4. A's cancel, b's cancel. 16 divided by 2 is 8. 1a cancels, so you're left with 1. And 2 of the b's cancel, so you're left with 1b. Done there. And again, you don't have to have this 1 right here. So there is the factored form for number 4. Alright, let's move on to some more examples. Okay, in this part we are going to talk about how to factor by grouping. And if you see our 3 examples at the bottom there, number 5, 6, and 7, you'll notice that all 3 of them have 4 terms. So I've given you some rules here on how to factor by grouping. And the first rule there is to group into 2 binomials. So right here, first step, group the polynomial into 2 binomials. So we're going to do this step by step with example number 5. So I'm going to take number 5 here, and I'm going to take these first 2 and make them a binomial, and then I'm going to take these last 2 and make them a binomial. Notice that I included the plus sign with the 3y. That's kind of important. So the second step up there then says to pull the GCF of each binomial. So I'm going to look at this first binomial, and I'm going to say, okay, 35x and 5xy. The largest number they're both divisible by is 5, so I'm going to take a 5 out, and then they both have at least one x, and that's it. So what's left over is 7. 35 divided by 5 is 7, and the x is gone. And then minus 1, negative 5 divided by 5 is negative 1. The x came out, but the y stays, so you just have the negative 1y, or if you want to, just negative y. So 7 minus y is left over. In the second binomial, 3y and 21, it looks like I'm going to take out a positive 3. Now, this is a key point right here. You have to write that sign there. You took out a positive 3, so I want you to write plus 3. If you took out a negative 3, you would write negative 3. Whatever the sign is, make sure you write it there. So I'm going to factor out a positive 3, and what's going to be left over is, well, if I take out a 3, all I'm going to have left over is y. And then if I take out a 3 out of the negative 21, I'm going to have a negative 7. Now, the next rule up here says make sure inside the parentheses are the same, or you've done something wrong. And if I look inside the parentheses here, are those two things the same? No. A positive 7 minus y is not the same as a positive y and a minus 7. So I've done something wrong. Well, the easiest way to fix this one, since they're so close to each other, is to actually, instead of factoring out this positive 3, I should have factored out a negative 3. And I know that now because the inside parentheses were not the same. So I factor out a negative 3, and let's see what happens. 3 divide out a negative 3 makes this now a negative y. Negative 21 divide out a negative 3 makes this a positive 7. Now is inside the parentheses the exact same? Yes, they both have negative y's and positive 7's. So now I know I've done this correctly. Last step then says to rewrite, and this is how you rewrite. You're going to take the two pieces that got factored out and write that as one binomial. 5x minus 3 is my first binomial. And then the two pieces that were the exact same, you rewrite as one binomial. Now, in this case, it doesn't matter if you write negative y plus 7 or 7 minus y. Doesn't really matter. But this is your final answer. These two binomials multiplied together will make your original problem. And again, how would you check this? Well, if you wanted to check, you simply take this and FOIL it now, or distribute it. I'm going to say 5x minus 3 times negative y plus 7. 5x times negative y is negative 5 xy. Negative 5 positive 5 times positive 7 is positive 35x. Positive 5x times 7. And then inside here I have negative 3 times negative y, positive 3y, negative 3 times positive 7, negative 21. So you look at this and you say, is this the same as my original problem? And yeah, I mean, it's out in the wrong order, but you have your positive 35x, your negative 5xy, positive 3y, negative 21. So that just confirms the fact that this was the correct factored form. So let's try this again now that we have a little bit of an understanding here. We're going to do number 6. Again, I'm going to just group my first two and my second two. First group, 2xy and 7x. 2 and 7 have no like terms, so I'm just going to factor out a 1, and then they both have an x in common. What does that leave me with? Well, it leaves me with 2y, because 2 divided by 1 is 2, and the x came out, plus 7, because you took out 7 divided by 1, and then you took that x out. Looking at this, again, negative 2 and negative 7 have nothing in common. I'm guessing, though, that since I want my leftover parentheses here to match this parentheses, if I want this to be a 2y minus, plus 7, it tells me that obviously up here I'm going to need to factor out a negative 1, not just a positive 1. It looks like nothing, this binomial up here doesn't have anything, but they always have a 1. You can always factor out a 1. It's just in this case I'm going to factor out a negative 1. So negative 2 divided by negative 1 gives me this positive 2. Negative 7 divided by negative 1 gives me this positive 7. And again, the reason being is because these two parentheses have to be the exact same. Now that they are, I take what factored out, 1x minus 1, and the second binomial is the leftover pieces that were the exact same as a single binomial. Done. Alright, and last one, same thing, first binomial, second binomial. I'm going to factor out a 3a, leaving with 5 minus b. Here I'm going to factor out a positive 4, leaving you with b minus 5. And as soon as I did that, I realize again these two are not the exact same because the signs are wrong. Well, I can easily fix that by going back to this positive 4, and instead of taking out a positive 4, take out a negative 4. Because now 4 divided by negative 4 leaves me with negative b, and negative 20 divided by negative 4 leaves me with positive 5. Now this and this are the exact same. So I have 3a minus 4 times 5 minus b. Done. Alright, one more part and we'll be done. Okay, so for solving problems in this section, we need to know this property right here called the zero product property. The zero product property states that if the product of two or more factors is 0, then at least one of the factors is 0. And if you really think about it, this is really pretty simple. What they're saying is if you have two things being multiplied together and the answer is 0, you know for sure that either the first thing is a 0, like 0 times 5 or 0 times 8 or 0 times 18, or you know that the second piece is 0, like 5 times 0 or 15 times 0 or 215 times 0, and it says that at least one of the factors is 0 because technically couldn't they both be 0? Sure, 0 times 0 is 0. So the zero product property is simply telling you that if the answer is 0, you know without a doubt that one of the pieces has to be 0 or all of the pieces can be 0 because that's the only way you're going to get a 0 as an answer. So because we know that property, we can now look at this problem number 8 and say, okay, I have two things multiplied together here. I have something, which we're calling x right now, times something else, x minus 24. So I'm taking two things and I'm multiplying them together. And the answer is 0. Well, what that tells me is that means either this first piece has to be 0, so x either has to be 0, or this second piece, x minus 24, has to be 0. So what you've done here is you've actually set up two small solving problems. The first problem is already solved. Your answer is either x is 0 or, and in the second part you add 24 to both sides and you get x equals 24. So for this problem there's two answers. If x is 0, this problem will turn out to be true. Or if x is 24, this problem will turn out to be true. And again, think about that. If x is 0, this is 0 times 0 minus 24 equals 0. Well, that would be 0 times negative 24 equals 0, and we know that's true. 0 times anything makes 0. So that checks out. Or you could look at it and say, well, that works, but what if x was 24? Well, if x was 24, you'd have 24 times 24 minus 24. Well, 24 minus 24 is 0, so now you have 24 times 0 equals 0, and again, we know that's true. So these two are both possible answers to problem number 8. So problem number 8 has two answers. Ignore that bell, sorry about that. So number 9, we look at number 9 and we notice it says the same thing. You have something, in this case this is the something, times something else, and the answer is 0. Well, because of that, you can say either this first thing has to be 0, x minus 2 has to be 0, or the second thing, 4x minus 1, has to be 0. And again, we have to figure out now what x is, but we know that this piece, this term, this binomial, or this binomial has to produce a 0, or both of them have to produce zeros to make the answer true. So if you look at the first part, we have add 2 to both sides, so x could be 2. Over here we add 1 to both sides, 4x equals 1, so then we divide by 4, and x equals 1/4. So again, if you would plug either of these answers into the problem, if you would plug 2 back into the original problem, your answer is going to be 0. And again, that's because 2 minus 2 is 0. 4 times 2 is 8 minus 1, so you'd have 0 times 7, which obviously does make 0. And the same thing if you plug the 1/4 in, because 1/4 will make this part 0. And 0 times anything over here is 0. So that's how you go about these solved problems. I'd go ahead and try the next couple yourself, except now that I look there, the next couple are slightly different. So let's look at number 10 together then. In this case, a lot of you guys are going to be tempted to just say 7d squared equals 0 and negative 35d equals 0, and that is absolutely wrong, because you cannot apply the zero product property to this problem because you don't have a product. You do not have a multiplication problem. You have a subtraction problem. Well, what we just learned was how to factor, and by factoring you turn something into a multiplication problem. So again, I'm really just going to undistribute here. I'm going to say, okay, these two pieces have a 7 in common and a d in common, which will leave me with d minus 5 equals 0. So now you have created a multiplication problem. You have something times something else. So either this has to equal 0 or this has to equal 0, since the answer is 0. So again, a simple solve step here. Divide by 7. 0 divided by 7 is 0, so d could equal 0. Add 5 to both sides. D could equal 5. And again, a simple way to check this is to just plug those numbers back in. Obviously up here, if you plug 0 in there, you'd have 7 times 0 squared minus 35 times 0. Well, that's 0 minus 0. Obviously that's going to equal 0. But what about this 5? If you plug 5 up there, so I'll just check that here real quick. I'll say 7 times 5 squared minus 35 times 5. Well, that's going to be 7 times 25 minus 35 times 5, which is 175. Then I need to do 7 times 25, which I'm hoping is 175. So I have 175 minus 175, which, yep, obviously that equals 0. So again, that's why we get two answers on these problems, because there are two answers. Two different things will make 0. Alright, and the last problem, similar to the problem number 10, only difference is this problem does not say equals 0 yet. Obviously, you're going to have to make your equation say equals 0 if you want to use the zero product property, which we do in order to solve. So we have to make our equation say equal to 0. Well, that's pretty simple to do down here by just adding 15x to both sides. Now I have 20x squared plus 15x equals 0. Now I can factor 20x squared and 15x. I think they have a 5x in common. That would leave me with 4x plus 3 equals 0. And now I can set each individual piece equal to 0. So I'm going to move this over here. So I have 5x equals 0, or 4x plus 3 equals 0. And now I just solve. Divide by 5. X equals 0. Subtract 3. 4x equals negative 3. Divide by 4. So x equals negative 3/4. So there are my two answers for the last problem, 0 and negative 3/4. Alright, that's all we're going to do for this video lesson. There is a story problem right below this that I would like you to attempt on your own, and then we will go over that problem in class together one day this week. Alright, start on your homework.